All right, so what we're going to do now is we're going to talk about base E derivatives. And it's a really good lead off of where we just left, where we were talking about derivatives of natural logs. And we're going to end up doing this a lot of the same way with, say, U substitution and all that jazz. All right, so let's get after it. Well, there's a nice rule. Derivative in terms of x of e to the x is e to the x. Nothing changes. Again, there's going to be a proof of this later. Not in this video, but later down the road, I'll show that to you. But right now, we got the derivative of e to the x is e to the x. Of course, it's not always an x. So let's talk about what happens in terms of e to the u. And that is just like it's been for the past 4 or 5 videos, U substitution, where the chain rule is going to apply. All right, so let's look at some examples. We have the derivative in terms of x of 4/9 e to the x. And just like before, if you don't do anything to this, we have to use the product rule. Since this is a constant, we'll use the constant multiple rule, and then we'll take that 4/9 and bring it out front. And now we have 4/9 times the derivative of e to the x, which is 4/9 e to the x. And of course, we could take this e to the x and put it back on top. So we have 2 versions of the answer. Fairly simple, okay? Now, I'm giving you this example because I don't want you to get into that tunnel vision. We're always just moving things out front. Well, you can only do that if it's a constant. This is not a constant, which means we are dealing with f times g, which is the product rule. This one we're not going to be able to avoid. So let's identify f and g. And then underneath this, let's write out the product rule. Okay, so we have f, 3x squared. We need to take the derivative of g. Well, g was e to the x. The derivative is e to the x plus g, e to the x, and the derivative of f, which was 6x. And the only thing that we have to do now, because we don't want to leave this answer like this, we want to see if we can simplify it or clean it up a little bit. So I'm going to look to say, hey, I have at least, and remember, I have a part here and I have plus a part here. So I'm looking at each part. I'm asking myself, what do they both have in common? Well, we can take out a 3. We can take out an x. And we can take out an e to the x. So let's see what that looks like. And what's left inside the parentheses is going to be the answer to this division problem here. Remember, when you factor, what's left in the parentheses is the result of the division of what you're factoring out. So you can see these 3's will cancel. I have an x squared and an x, so I'll be left with 1x. And these e to the x's are going to cancel. So the only thing left here is x. Let's bring our addition back down. And what's left over here? We have an e to the x that's going to cancel with e to the x. We have an x that will cancel with an x. And we have 6/3, which is 2. So there's the answer to this product rule. All right. So now we've got something other than x. And every time we see something other than x, we think U substitution. And let's write the rule in terms of U. E to the U times U prime. So now we get this chain rule. And just like all the other videos, I'm going to be over here just taking notes. I need a U prime, so let's take the derivative. And now I have 2 pieces of information I need. I need the U, which is here. I need the U prime, which is here. Let's toss that in. And the only thing to do now is bring this 2 out front. That's the standard way to write that. And there we are. So nice, easy rule, nice, easy derivative. Okay, and then the only thing I'm going to do probably for the next 4 slides is just to complicate what we're going to call U. Let's look at another example. This is the derivative in terms of x of e to the negative 5x cubed. So there's my U. Jump over here. Let's write the rule. And again, it just reminds us we need the chain rule, which is the derivative we need over here. So let's take that derivative. Let's take these 2 pieces of information and throw them in. And again, the standard way to write this answer would be to take this and bring it out front. And there's the answer. Okay, let's throw a fraction in for fun. We have the derivative in terms of x of something other than x, so we're thinking u sub. Let's write the rule. We need its derivative. And this derivative over here is, remember, we're going to multiply 9 down. So we're going to end up with 9 times 2/7, which is only going to affect this 2. And we're going to end up with 18/7 x to the 8th because we're taking 1 away. All right, let's take these two pieces of information and throw them in. And I'll be honest with you, you could take this entire thing and just slide it up front and write the answer, and it would be absolutely perfect. I'm going to just show you a different way, just to remind you that when we have fractions involved, we might want to write things in terms of fractions, condensed. So I look to see what can be in the numerator position, and I would just look for the positive exponents. So this can be in the numerator, the 18 can be in the numerator, that x to the 8th can be in the numerator. So all 3 of these can be on top. The 7 is going to go on the bottom. I'll just write it in terms of a fraction. 18x to the 8th, e to the 2/7 x to the 9th, and that is over 7. So that's one good way of writing the answer. Okay, let's complicate this a little further. Let's make it a radical. So again, it's not an x, so let's think u sub. And I'm over here, and again, I keep talking about, this is where I put all my notes, and I took it a step further. I took u is equal to 2 root x, but I knew I needed its derivative down here, so I put it in a form I can take its derivative. So 2x to the 1/2, this is going to allow me to use the power rule. So let's take its derivative. Here's the rule. Let's take its derivative. And this 1/2 would be multiplied down, which would give me half of 2, which is 1. And then take 1 away, which would give me negative 1/2. And we can also go, well, I can move that down, which would give me this form. And of course, I could put that back as a radical. And again, when I take my u and I'm bringing over, I'm going to grab the best form possible, which is this radical form. And when I grab my u prime, I'm going to grab it also from the radical position. So I'm going to grab this and put it here. And I'm going to grab this and put it here. And the only thing left to do here is just clean it up. So all of this can be on top right here. And that root x can be on the bottom. So that is one way of writing the answer. Or we could go back to our algebra 2 and our pre-calculus days and remember, well, we rationalize denominators to get rid of this radical on the bottom. So I'm going to multiply top and bottom by the square root of x. And it would give me that form right there. All right, I think it's the last example for u substitution that is not going to complicate our life even further. So let's look and see, well, what are we going to call u? Let's write the rule. And this is a nice, easy derivative. Derivative of u is u prime. Derivative of tangent is secant squared. Let's grab this information and toss it over. And that is actually the form of the answer I want to write it in. We don't want to grab secant squared of x and bring it out front. We want to keep the trig function on the back because this would ultimately represent almost, well, in essence, the amplitude of this trigonometric function. So we're just going to leave it like that. All right. I've got 2 examples left where one, we now have a product rule. And then when we take the derivative of this piece, I'm going to be thinking e to the u prime. So I've got a couple rules kind of together now. So let's think about f times g, and that would give me the product rule, fg prime plus gf prime. Let's identify our f and our g. And then underneath this, what I want to do is just pause it right now and see if you can write this correctly. Okay, well, that's what I got. I got f standard, left it alone. I got x cubed. And then I was over here and I'm saying, well, I need to take the derivative of g. Well, I needed to take the derivative of that, which followed the rule e to the u prime, which gave me 4 e to the 4x. Now, you may have written e to the 4x times 4, and that's fine. I just put the 4 back in front, just out of habit. We have a g. I left that alone. There's my e to the 4x. And then I took the derivative of x to the third, which was 3x squared. And then from here, I'm going to look to see what I can factor out. Something from this piece, something from this piece. What do they have in common? Well, you can see they have at least an x squared they share. Or I shouldn't say they share it. They have it in common. The 4 and the 3, there's nothing I can do with those. But they do have an e to the 4x in common. So I'm going to factor out x squared e to the 4x. And remember, what's left in the parentheses is the answer to this division problem here. You can see, well, an x will be left over. A 4 will be left over. These will cancel. So only thing left here is 4x. Let's bring the addition down. And what's left over here? These x, e to the 4th, e to the 4x's will cancel. These x squareds will cancel. I'll be left with 3. And that's a good way of writing this answer. There is the product rule with an e to the u prime involved. Okay, let's do one with a quotient rule. And I'm not going to do it this way, but I want to point out that you could take this e to the x and bring it up and would have made it e to the negative x, and then you could have done the product rule with that. But I'm going to leave it alone. I'm going to leave it in the quotient rule form, which is right there, gf prime minus fg prime over g squared, and identify what I'm going to call f and g. And then underneath this, go ahead and pause it. See if you can write this correctly. Okay, well, that's what I got. I wrote g, I left it alone, there it is. I needed f prime, so I took the derivative of 3x, which was 3, minus f, which was 3x, there it is. And I took the derivative of g prime, or I took the derivative of g. So I took the derivative of e to the x, which was e to the x. And that's over g squared, so I just put g squared, okay? Now I'm going to go over here. I'm going to do two things. I think I'm going to do two things. Let's see if I'm wrong. But I am going to bring this 3 and bring it out front. And I'm going to square e to the x. Now this is where somebody's going to goof. I see this a lot year after year in my class. And someone's going to go from here to here and write e to the x squared. They're just going to square the x and bring it over here. And that's not correct. What we have here is we have an exponent and an exponent. So anytime we have an exponent of an exponent, we have this algebra rule that was called the power of a power rule. Sorry, I almost had to think about that. It was called the power of a power rule. So when we have an exponent of an exponent, what the rule says is you simply multiply your exponents together. So e to the x squared is e to the 2x, and that was because it was 2 times x, which is right there. And I moved that 3 out front. Okay, so the only thing I have left to do is ask myself, can I factor something out? And you can see these both have a 3 I can take out, and they both have an e to the x I can take out. So let's take out the 3 e to the x out of this. I left that alone. So if I take out the 3 e to the x right here, I'm dividing by it. Well, 3 e to the x divided by 3 e to the x is 1. And if I divide this by 3 e to the x, the 3's would cancel, the e to the x would cancel. I'd be left with x. So there's the best answer for this quotient rule. All right, well done. Nice job.